In this problem, we're asked to look at a shaft, which is really made up of two parts, 1 and 2. One is a tube, and 2 is a solid shaft. One is attached to a wall on the left side there at B. 1 and 2 are connected by a rigid connector there at C, and then there's a rigid connector there at D on the right hand side of 2, onto which a torque T naught is applied. Our goal here is to determine the angular rotation of a rigid connector D using an energy approach. Along the way, we're asked to find the strain energy U, the work done by torque T naught, use the work energy principle to find that rotation, as well as Castigliano. So our goal here on part A is to come up with the strain energy function, which is U, and it's going to be made up of two parts, 1 and 2. 1 is going to be 1/2 the load that's carried by 1. The load in this case is not a force, but it's a torque. So it's T1 squared times its length L over 2, GIP1. For 2, it's 1/2 the torque load carried by 2, its length L over 2, divided by GIP2, where IP1 is equal to pi over 2, 2d over 2 to the fourth, minus d over 2 to the fourth. So that's going to be equal to 15 sixteenths of pi d to the fourth. The second polar area moment for 2 is going to be pi over 2, simply 2d over 2 to the fourth, so that's going to be equal to 1/2 pi d to the fourth. So what we need actually, before we can say we've got the strain energy done, is we need to do some equilibrium in order to find the relationship that exists between the applied torque T naught and the loads carried by 1 and 2. Our standard procedure in this course has been to draw FBDs of connectors. We'll continue to do that here. So this is the torque carried by 1. This is the torque carried by 2. This is what's happening on C. Equal and opposite force or torque there on D, and the applied torque there of T naught. And if I look at D by itself, do a moment equation on that, I get T naught minus T2. So the torque that's carried by 2 is nothing other than the applied force T naught. If we go into C, do a moment equation, we receive the same kind of thing. Minus T1 plus T2 says that the load torque carried in 1 is the same as it is for 2, which is equal to T naught. So what that means is U then is equal to 1/4 T naught squared L over GIP1 plus 1/4 T naught squared L over GIP sub 2. We also need to find the work done. The work in this case is just due to T naught. So that's going to be equal to 1/2 the torque times the angle of twist there for D. The work energy equation. That equation says that the work being done, in this case just T naught, must be equal to the strain energy in the system. So this becomes 1/2 T naught phi sub D, and that's equal to, according to our equation above, 1/4 T naught squared over L GIP1 plus 1/2 T naught squared L over GIP2. And so we can cancel out the T naught along the way. And we cancel out the 2's to get 4's here, so phi sub D then is equal to 1/2 T naught L over G times 1 over 1, oh, sorry, 1 over IP1 and 1 over IP2. So that's coming from the work energy equation. C, we use Castigliano. Castigliano says that if we want to find the rotation at D, we simply need to take the partial of U with respect to the torque that's acting at that point, and that is T naught. Going back to the expression for U, we end up with 1/2 T naught L over G IP1 plus 1/2 T naught L over G IP2. And just rewriting that in a slightly different way, I get 1/2 T naught L over G over 1 plus, multiply 1 divided by IP1 plus 1 divided by IP2. So this checks. So as long as the work energy equation allows us to get an answer, it should agree with what Castigliano gives, and those two results are the same. So again, using the energy approach, the key things are: 1, writing down the strain energy function. That requires us to do some equilibrium analysis to relate the internal results, the torques in this case, back to the applied torques. It relies on us being able to find the work due to the loads that are acting, and we use both of those for the work energy equation. For Castigliano, we only need to have U. In this case, of course, the two methods gave us the same thing.